Welcome to the channel. This is the first episode of the Python Pandas series. We'll be going through the main concepts of Pandas. Pandas is a powerful and widely used Python library for data manipulation and analysis. As AI is getting better and we are being more reliant with AI, it is very important to understand the main concepts of a library to have a solid understanding of what the code is doing when it's being written by AI. This video series will give you a solid foundation to work with. Like and subscribe if you appreciate these videos. Let's get started. We will be talking about the two main data structures used in Pandas, series and DataFrames. Let's start with talking about series. A series is a one-dimensional labeled array that can hold any data type, and it is a building block of a data frame. You can treat it like a column in a spreadsheet. A series consists of two main components. The first component is an index. Each value in a series has a label or an index. By default, it is a sequence of numbers starting from 0, but you can also customize it. The second component is the data, which is the actual data stored in the series. So a series typically contains data of the same type, but it can also hold mixed types. You can create a series using the pd.series constructor. Make sure you first have pandas installed and you import it in your program. And we can try running the program. So here you see the left column is the index, which is automatically created, and by default it's a sequence of integers. And the right column is the data itself. The D type shows the data type of the series. You can define a custom label for the index by using the index parameter when you create your series. You can create a series with a dictionary. When you create a series from a dictionary, the dictionary's keys become the index, and the values become the data. You can access an element in a series by using the index. Here we're trying to access index A. You can slice a series using labels or positions. In the first print statement, we are slicing by the label, which is inclusive, and in the second print statement, we're slicing by the position. You can perform basic arithmetic operations on series. Here we have two series, S1 and S2. The first print statement, we're going to add both series together. In the second print statement, we are going to multiply the values in series 1 by 2. Pandas automatically aligns data based on the index during operations. This is quite a powerful feature to ensure consistency. Here you see we have two series, and the index for series 1 starts with A, B, C, whereas the series 2 begins with B, C, D. So let's see what happens when we try and add series 1 and series 2 together. The indices A and D did not overlap, so the result is not a number for these positions, and we were only able to add the index B and C. This behavior again ensures that the operations are performed only on aligned indices. You can use Boolean conditions to filter a series. Here we have a series and we're trying to filter out the elements that are greater than 20. So Pandas supports method chaining, where you can perform multiple operations in a single line. In this statement, we are going to first filter out all the elements that is greater than 20, and then add 10 to every element, and then we find the total sum of the series. You can use isNA to detect missing values in a series. This will return a series of Boolean values. And on top of detecting missing values, we can also fill in the missing values with fillNA. In this print statement, we're choosing to fill the missing values with 0. The second main data structure in Pandas is a data frame. A data frame is a two-dimensional labeled data structure. It is similar to a table and is the most used Panda object. A data frame consists of three components: columns, rows, and values. Each column is a series itself. Each row has an index, and the values are the data. You can create a data frame by using the DataFrame constructor. If you build a data frame using a dictionary, the keys of the dictionary becomes the column names, and the values in the dictionary becomes the data in the columns. Similar to a series, you can specify a custom index for the data frame by using the index parameter. You can also create a data frame using a nested list. only the values will be populated. You'll need to name the columns yourself. You can access a single column by calling the column's name. This will return a series. Or you can access multiple columns. Here we call the name column, and the second print statement we call both the name and age column. We can access specific rows using lock and ilock. Lock retrieves a row by the label, and ilock retrieves a row with integer-based indexing or the position of the row. Here we see we printed out the data frame as a reference. We use lock to get the 0 index, whereas we use ilock to get the row that is the third position. We can access specific elements with @ and iat. Similar to lock, @ retrieves the element by label, and iant retrieves the element by position. In this example, we first printed out the data frame as a reference, and then we use @ to get index 0 in the name column, which is Alice, and then we use iat to get index 1 in position 1, which is 30. You can add a column by assigning a new list to the data frame. Here we made a new column, siblings. You can delete a column by using drop. You need to pass in the label you want to drop and declare which axis it is on, 0 for row, 1 for columns. You can then pass in true for the in-place parameter to let Pandas know you are performing the drop on the actual data frame and not on a copy. Similar to series, you can filter a row by giving it a Boolean expression. You can also sort values by using the sort values method. Here we sorted the age by descending order. Just like series, you can detect missing values by using isNA, and also fill in the missing values with fillNA. We just went through the foundations of series and data frames. Just before we end things, I wanted to go through the concept of a copy and view. Understanding whether an operation returns a copy or a view is crucial for avoiding unexpected behavior. So we create a view when we assign the series or data frame to a new variable. We can also create a new copy by using the copy function. Any modifications to a view affects the original data structure, while the original will not be affected if we modify the copy. Here we see we have a data frame, and we create a view, and we also created a copy of the view. We try to modify the view, which would affect the original data frame, whereas if we were to modify the copy, it doesn't affect the data frame. As you see, we're printing the data frame 2 times. The first time is after we modified the view, and we can see that the data frame has been modified, and then we print out the data frame again after modifying the copy. But this time we can see that the data frame is unaffected. Thank you for watching until the end. We went over the main concepts of series and data frames. Comment if you learned something new from this video, and stay tuned for more videos on Pandas.